Hi, everyone, and welcome to the first lecture of the Information Visualization course. I am your lecturer and course coordinator, Jan Zahalka. And before we get to the content of the course, please let me introduce the team. So your TAs are going to be in alphabetical order: Aritra, Inske, Ivona, Georgi, and Yunhua. And they will be supervising and guiding you through the practical part of the course. And we also have a senior TA, that is Christina, who should be here with us today. And she's going to be providing administrative and organizational assistance with the course. She's going to be chairing the lecture sessions and taking Discord questions. Let me see. I'm gonna see if just check if everything is working properly. Yeah, you can hear me. I can see, so that's perfect. Yes. So yes. So let's continue. She will be chairing the lecture sessions and taking Discord questions, and she will be organizing and overseeing the project teams. So the communication during the lectures, because we are in the online era of teaching, we wanted to set up some nice way to efficient communication so that everybody gets the best experience. As you might have noticed, there is a Discord server for the course. The invite is on Canvas homepage in the communication section, and you will want to pose your questions during all lectures, including this one, in the respective Discord channel. The reason for that, using that instead of Zoom chat, is that it's very cumbersome to archive the conversation on Zoom because that's usually tied to the meetings, and we want to make Discord into a secondary study resource. So we're going to have channels for each lecture. So there's already a channel called lecture 01 right now, so you can post your questions in the Discord, and Christina is going to relay the questions to me interactively during throughout the lecture. So we're not going to have specific time for questions at the end. Please feel free to write your questions as you come up with them, and we're going to try to answer them live. If you want to ask a question in voice, please raise your hand in Zoom. And then you will be able or Christina will unmute you, and you will be able to ask your question like it's a normal lecture. Yeah, I see a question that yeah, there it is. It is there, the communication section. Yes. So just before we proceed, Christina, could you briefly unmute yourself and see that you can indeed jump into the lecture?
Hi, can you hear me?
Yes, I can hear you perfectly.
Okay,
so,
great.
Very
we
good.
already have like one question. Will the students have access to the lecture slides before the lecture?
If that's needed, I will try to do so. The original plan was to upload the lecture slides right afterwards, but in principle I don't see a problem with trying to upload it before. So like if I miss one, then please bear with me. I will try to change this flow then. Yeah. And okay, so let's proceed. So what we're going to be talking about today. So today is the intro lecture. So I will try to go light on the content. We're gonna introduce what information visualization is. We're gonna have some. We're going to look into the history of it and the current disciplines, and at the end we will talk about the organization of the course. So what is information visualization? So there are multiple definitions. In this slide, I have selected two what I believe useful ones. First, you can define information visualization through the goal. So the goal is to design a visual representation of data that enables or facilitates useful understanding. And the useful understanding is a bit of a vague term, but we're gonna see why later in the course. If you prefer a more math style definition or intuition, you can consider information visualization, the mapping between data and a visual representation. If we think about what the original visualization is, and now we're starting with the history part of the lecture. The original visualization is actually numbers, right? Because the need to conveniently record the count of various objects is as old as civilization. And indeed, the original numeral system, which is still used to an extent today, are telemarks. So that has already been recorded in the prehistoric era, and it's still useful for small numbers. I don't think that we need to go into detailed explanation what it is. You just make a stroke for each of the objects that you want to record. It's very intuitive. It's if you would be asked as a child to create a numeral system, you would probably create a variant of telemarks. Here we have the numbers of 1 to 10, and you can already see that towards 10 we start to have problems with readability. So there might be some issue with these numeral systems. And indeed, readability has improved over time. So in continental Europe, people are mostly grouping it by fours, and then the fifth one is complete 1 5, and you position the fives next to each other. That's also very intuitive and known. But I mean, you can still see that if I ask you to write 370, then it would be very difficult to read that number back. The ancient civilizations were already aware of the telemarks being insufficient. And one of the first recorded numeral systems that is a bit more advanced was Babylonian, that appeared in between 3000 and 2000 BC. What is interesting is that the Babylonians used the base of 60, unlike the base of 10, which is common in most of the numeral systems. They have used 60, maybe because it factorizes nicely, maybe because it's related to time. We don't know for sure. And they used two basic symbols, 1 for 1, 1 for 10, and it was compounded to form the digits. So you can see that all those things you see here are individual digits, and they were positioned next to each other to form higher numbers. Another ancient system that is my favorite personal, that is more closer to what we have today, was the Egyptian one that arrived at roughly 2000 BC. That one is already base 10. It's better suited for large numbers because you see that we have glyphs for larger numbers. So here's an example from a tablet excavated from Karnak, which contained the number 4622. What I especially like is that the Egyptian system seems to be aware of the challenge of scale, because they have the glyph for 1 million or more, or many, is pretty much a guy giving up. And we see that there is some wisdom in that to this day and age, we have big problems processing data sets that contain a million items or more. So this was quite ahead of its time. The Egyptian system is remarkable because they have introduced some more advanced math concepts, such as fractions. You just put an I above the number, with the numerator always being 1, and sums being used to express fractions with numerators that are other than 1. So if you want to express 5/8, you do 1/2 plus 1/8. And there were special symbols or shortcuts for the most commonly used fractions, even ones with non-1 numerators, such as 1/2, 2/3, and 3/4. 3/4 rather. Yes, here are a couple of the other examples of numeral systems. This is pretty much to illustrate that old civilizations around the world did have their numeral systems, different ones, and that the need for indeed having numbers was universal to across the world. And an interesting topic is the concept of zero, which for which there was not a convincing explanation up until rather recently, or surprisingly recently. Because zero was obviously known in the sense of absence or nothingness in the ancient civilizations. They even had symbols for it. So even in both the Babylonian and the Egyptian numeral systems we have discussed previously do have a glyph for zero or absence, nothingness. In ancient Greece, but it was not a number. So my intuition is that this was akin to infinity. So we use the infinity symbol, but we don't really do math with it. We don't. It's never really a part of a number. It's like a placeholder symbol to an extent. So these glyphs should be understood as such. In ancient Greece, zero was a philosophical issue. So the question was, how can nothing be something, basically? So how can you have an object meaningful representing zero other than absence or nothingness? And as we know very well today, zero is a very useful number in math. And the current notion of zero as both an expression of nothingness and a number was invented by Indian mathematicians at latest by the 7th century of Common Era. So quite later than the appearance of first numeral systems beyond telemarks. It comes as a no surprise that the current system that we use is the Hindu-Arabic numeral system, but here we are at the information visualization course, and we want to ask why. So beyond the historical reasons, what makes our numbers a good visual representation? So the answer is mathematical convenience, because your arithmetic operations are greatly simplified with writing the numbers the way we do, because you can imagine Egyptian numbers or Roman numbers, or choose your another favorite historical numeral system, and imagine doing advanced math with that. What is really nice about our system is that we have arbitrary precision. And also for let's say bookkeeping, accounting purposes, the positional notation really makes it easy to compare numbers, especially when they are right aligned. And this is a combination of the positional notation and the fact that we only have 10 digits, regardless of the value of the number, of the scale of the number. And we have this nice relation that the higher the value is, the greater or equal the length of the number. So so the mathematical convenience is illustrated by this. You can do something like this, and you know we know what this means, and the advantages of the positional notation is expressed here. So here we have our Hindu-Arabic numbers and the Egyptian numbers, and you can see that at a glance you can quickly see which one is the largest here, but here it's a bit deceptive, right? Because the largest number is actually the shortest one. So they are by length, they are sorted in ascending order. So the smallest number is the longest, then the second longest is the second largest number, and the largest number is the shortest one. So that is a bit deceiving. So that's one good reason why to use Hindu-Arabic numbers. Another advantage is that the individual digits are distinct, and yet they are very easy to draw. So you know, if you would want to write Egyptian numerals, you would have to study calligraphy pretty much. If you want to write normal numbers, then you learn that at the first grade of elementary school. Regarding the distinctiveness, I'm aware that we have a lot of AI people in the audience. So whoever worked with the MNIST dataset, that's the dataset images of handwritten digits, they might beg to differ because it's wonderful what creations some people can write as numbers. So for instance, I like that here we have the confusion matrix. The rows are what the numbers actually were, the ground truth, what the people actually wrote or thought they wrote, and the columns are predictions. So what an AI model predicted the numbers actually are. And I mean, sometimes the model makes clear mistakes, but I mean this one that it's a 2. I don't know. Like I could also read it as a 9. So I mean, yes, sometimes people can write in their own very distinct style, but this property in general terms holds. So why are we saying all this? Like, why did we have numbers as an introduction? Well, again, recall that visualization is a mapping from data to a visual representation. So the need for numbers is you own 4 cows and you want to record them somewhere. And this mapping is actually not naturally intuitive, because if you would be, let's say, an alien and coming to Earth, and you would see that this is recorded as this, like, why? Why is this representing 4, right? It's not even 4 lines, you know, why? So because telemarks are very intuitive. For each cow you do a stroke, right? But this or our numbers, they became intuitive for very profound reasons that we have discussed, that they're convenient. It's just the best system that we have. It's a well-designed and useful numeral system, and basically designing new visualizations that really become intuitive and enhance thinking about the data is exactly what we aim for with information visualization. So if you would design something as intuitive as the Hindu-Arabic numeral system for some kind of data, then you would be a world-class superstar pretty much in InfoVis. So this concludes the early part of the history. Let's move on to through the ages, basically. So the another visualization that is commonly used and often not even thought of as visualization are tables and charts. So tables have been used from at least the Middle Ages, especially in finance and trade, quite possibly much earlier. It's that we're completely sure that by the Middle Ages there are proven records of people using tables extensively. So those are a very old visualization technique. Regarding charts, charts were for a long time part of what is called statistical graphical methods, and the founder of that discipline is William Playfair, who lived in the 18th and 19th century. And the first line, bar and area charts were devised in 1786, and the first pie chart in 1801. But let's show and not tell. So this is the first line chart published. Here we see that those are exports, trade balance between the United Kingdom and Denmark and Norway, which I believe used to be one country back then. And you can see that Playfair has done, like for the first visualization or for the first chart, he has done a lot of things right. Actually, all of them pretty much. So he has clearly labeled x-axis, y-axis. He has plotted a line of imports. So this is the absolute value of imports from Denmark to the UK, and the red one is the line of exports. So how much the United Kingdom has exported to Denmark, Norway. And he has also made use of the area chart technique, where he nicely plots the relations between the two. We can see the breaking point. I mean, one critique maybe, if I could. I mean, it's difficult to critique the forefather of visualization, but I mean, it's maybe he could have swapped the colors here, right? That the balance against UK, it means it's dominant imports, and the imports is the yellow line. Exports are the red line. So maybe he could have thought of swapping that, but that is if I would really be nitpicking, because this for 1786, this is an amazing visualization, and we're going to see very soon that there are many bad ones, even today. So he founded statistical graphical methods, and in the 19th century there was one more remarkable case of using visualization for analytics. So in 1854, in the Soho district of London, there has been a cholera outbreak. There have been 616 cholera-related deaths in a small area, well, in Soho. Back then, it was rather unsanitary, even for the time, district with many colorful characters living there. So it was not exactly a well-organized, upscale neighborhood. But still, a lot of deaths in a very small area, and it was suspicious. There was no unified theory for the cause. So why did this happen? The prevailing opinion was that the disease spread by miasma, which means foul particles in the air, that they were hanging in the air, and whoever breathed the air got sick. The correct theory is actually the germ theory, that cholera spreads through germs in water and soil, but that has not yet been formulated. So it has been a mere hypothesis, and the powers that be in the municipal government were operating with the miasma theory. But then there was this guy called Jon Snow, unrelated to the popular Game of Thrones series, who was really suspicious. So what he did is this. What you see here is a map of Soho, and he has plotted the water pumps that dispense water, because back then people had to collect water from a communal water pump, and for each death he has recorded the address as this little tally mark. So you can see that there are 4 deaths in this house and so forth. And I mean, just looking at the map, but this was a very innovative way of thinking back then. There seems to be quite a cluster, and it seems to grow in strength towards the epicenter, which seems to be around here. And what do you know? There is a water pump right here on Broad Street. So what he has done a very simple counter-epidemic measure. So he has removed the pump handle from the Broad Street pump, so people could not pump water from it, and the outbreak indeed subsided. And further measures were then taken to improve sanitation further. What is interesting is that there has been significant political opposition to Jon Snow's theories, even though he had everything based on data. So that we can see from some of the stories that of COVID that this might be still the case. But nevertheless, Jon Snow is considered one of the founders of modern epidemiology.
Jan, just to notify you, 2 more minutes.
Okay, so it might actually be a good idea to take a break right here. And first, are there any questions on Discord or?
There was one question about what arbitrary convenience means, but I think a student already answered it in the Discord chat.
Okay, very good. So I mean, we can take a look at what was it, but if it's answered, then that's fine. Perfect. So if there are no further questions for now, so that's what I didn't fail to say in the beginning. We're going to have this lecture chunked into 4 parts. We can take a 5-minute break now. So now it's 9:24, and we can reconvene at 9:29, let's say, no, or 9:30. So please take a 5-minute break, and I'm going to start talking again in 5 minutes. All right, so let's continue with the lecture. So we're going to move beyond the Broad Street cholera outbreak towards the work of Charles-Joseph Minard. He was a French traffic engineer who was planning traffic infrastructure or new roads, etc., by the extensive use of flow maps. And the pinnacle of his work, or his by far most famous visualization, is this visualization of Napoleon Bonaparte's Russian campaign in 1812 and 1813. That was a very disastrous campaign from the French point of view. where the French have started with with a huge army, and throughout their campaign in Russia, they have lost the vast majority of their soldiers. So here we see the flow that the light brown is the campaign towards Moscow, and the black one is the retreat from Moscow. So you can see how the army is bleeding soldiers as they get closer and closer to Moscow, and then when they retreat, it gets even more disastrous. One more thing, interesting thing he has done, he has correlated the losses to the temperatures that were in Russia at the time. So you can see how the temperatures were progressing lower and lower, and he nicely marks key points which had an influence on the losses of life in Napoleon's army. So this is one of the this is actually, I think, the first infographic ever, and there is a lot of design things done right. So Mina has done this as a retired person, and he has died a couple of months later. But this work of his has become pretty much immortal. So this indeed is an example of good infographic design, as we're going to see later. Moving towards information visualization as a specific discipline. So we have been talking about charts, plots, and so forth being called statistical graphical methods. They still are today. And indeed, for most of the 20th century, there has been widespread use of static visualization. So if you open your newspaper, you could see plenty of line graphs, bar charts, and whatnot. Visualizations were used, but back then it was on rather digestible data sets, so the visualizations were fully static. I mean, it's difficult to animate a piece of paper, right? And it was only in the 1980s to 1990s when information visualization emerged as a full-fledged computer science discipline, because data became more complex. So it was no longer enough to analyze them by summarizing them in a simple chart. And also computer graphics became powerful enough to support more intricate visualizations. And indeed, the first InfoVis papers were published at computer graphics conferences such as SIGGRAPH. The two classic books that are considered cornerstones of information visualization theory are the kind of ahead of its time book called The Visual Display of Quantitative Information by Edward Tufte, and Readings in Information Visualization Using Vision to Think by Stuart Card and Collective is also a nice piece. So these two books paved the way towards setting InfoVis in stone as a self-standing discipline. Here we have a nice 90s example of a visualization. We see this beautiful Windows 3.11 style window. And this is work by Catherine Plazan and her team. That is it was used by social services in the US to map problematic parts of people's lives so that they can direct help towards them more efficiently, so they can understand their demographics a bit better. There are multiple examples from 90s that I could have used, but this is a famous one which has collected a lot of citations, so it's one of the cornerstone papers. Around the turn of the century, there has been a bit of a pivot towards a new subdiscipline of information visualization, because data has become increasingly large, dynamic, and important. And the catalyst of that thinking were the 9/11 terrorist attacks, because the prevailing conclusion, not only from the government agencies, but also from news media companies and other involved parties, citizens, were that we had the data somewhere, but we didn't have the tools to analyze them. So we are funding all these government agencies, but then we still get an attack like that. So how could this have happened? So since then, the US government, but not only the US government, and not only for security purposes, have funded creating a research agenda for a new kind of discipline that would create tools that can harness modern data and analyze them efficiently. So this discipline is to this day called visual analytics. That agenda has been published in 2005. It's called Illuminating the Path. Because it was funded by the US government and it's in the public domain, you can actually read this book for free online. And if you're interested, it's not mandatory for the course. But since then, we have had a lot of new tools in visual analytics for that data sets way beyond security applications. So we have in traffic, infrastructure planning, medical sciences, astrophysics, news, media, marketing. A lot of domains that use data now use visual analytics tools. So before we go into the unpacking information visualization and modern era information visualization a bit more, one more recall stop. Recall the two definitions of information visualization. So it's about the visual representation of data that enables or facilitates useful understanding, or a mapping between data and a visual representation. If you want a pipeline, so this is roughly the information visualization pipeline. There is a reason why it's drawn this strangely. We're going to see the reason later in this lecture. So basically, you start with your problem, you collect your data, you more often than not have to process the data, and you might need to take a couple of turns. Then you design your visualization that can be interactive, so you're not just looking at a static chart, but rather you're interacting with the visualization, and then you hope to gain some knowledge, which either can be enough for you, or you need to go back to collect more data and start the process all over again. So this would roughly be the pipeline from the design perspective. And in the beginning of the lecture, I have talked about information visualization having multiple definitions. So we can go over some other ones beyond the goal and mapping style definitions. So Daniel Keim, who is one of the founding fathers of visual analytics, says that InfoVis is communication of abstract data through the use of interactive visual interfaces. Purchase says that InfoVis utilizes computer graphics and interaction to assist humans in solving problems. The Wikipedia definition is that it's the study of interactive visual representations of abstract data to reinforce human cognition. And Stuart Card, the author of one of those books, says that it's the use of computer-supported interactive visual representations of abstract data to amplify cognition. So there is no unified definition for what InfoVis is, but it's a union of all these. So I hope that this sheds some more light on what the discipline actually does. So we're saying that we're going from mapping to we're going with a mapping from data to a visual representation. So let's unpack both of those two terms. So data in InfoVis generally means large and or complex data, which has any or all of the following characteristics. It has many data types, large number of data instances, large number of attributes, that you have to join data from distinct data sets, or you have to contend with noisy, unreliable, or missing data. Because if you don't have a data challenge, if your data is clear, nicely formatted, nothing wrong with it, then you can just plot the data in your favorite tool, and it's not an information visualization challenge, right? If we look at data from the point of view of data types, the correct answer is basically everything. All kinds of data are up for grabs for visualization, and if you manage to visualize a data type that has not been visualized before, then it's an easy paper for you, or it's an easy way to make your mark on the field if you do it right. But to be a bit more structured about this, the 7 basic data types as defined by Schneiderman in, I think, even 1980s, where that you can have 1, 2, or 3-dimensional data, multidimensional data, temporal data, so evolution of some variables over time, trees, networks. And in the modern era, we have even richer data, an example of which could be geospatial data or multimedia data. So that means that you can have text corpora, image data sets, video data sets, or audio data sets, and you can have combinations of those. So for instance, you can have image and video data sets. So the videos also include audio, and the images and videos are accompanied by, let's say, user comments. And you want to mine all of these in synergy. And there are even more types of data. So this list is non-exhaustive. Please bear this in mind. If we go into the basic variables, so if you look at what you can have in a table, so because your most common data that you're going to be visualizing is going to be in tabular form pretty much. So you're going to have your rows are going to be data items, and your columns are going to be various attributes or variables. And we're gonna go in a bit of detail what the basic variable types are. So you can split them into qualitative, word descriptory, and quantitative or numeric. So one of the basic types is the categorical or nominal variable. Those are qualitative variables. They are simply names, which from the programmatic point of view are short strings, or DB type point of view are short strings that are attached to data items as labels. And them being labels means that they come from a small predefined set, so it's not free text. Some of them in classification, if you're doing AI, you can use those as classes. That's how they behave, and they categorize the data into useful groups or categories. An example of categorical variable is if you have a data set of cars, is the car brand. So here you have examples of car brands. And the relationships between those values is that BMW is different than Ferrari, both are different from Jaguar, and so forth. That's the only relationship that you can have. What category the item, the data instance falls in. Another type of variable is the ordinal variable. That one is again qualitative, and the values, so those are categories, but in addition, the values establish a rank ordering of the entities measured, or rank ordering of the variable values, so to say. So I'm actually going to jump into the example right away. So you can see, if you're skiing in Europe, there's a universal difficulty system for the ski piece. So the easiest slopes are the blue ones, the intermediate ones are the red ones, and the hardest slopes are black. So there is a relationship. So blue is less difficult than red, and red is less difficult than black. That's the ordinality, the rank ordering. And you can see that ordinal variables are either numbers, or they can easily be mapped to integers. So an example of that mapping is that your lowest rank is going to be 1, and R is going to be the highest rank, where R is the number of possible values. So it's going to be 1, 2, or 3. So you can encode this as numbers and compare those numbers meaningfully. The next type of variable are the interval variables. Those are already quantitative, so those start behaving like real numbers. Interval variables are ordinal, so you can compare any two values, and also differences between two values are meaningful. So x1 minus x2 makes sense. This also has consequences of equal differences, meaning equivalent intervals, and that you can compare differences between any two values meaningfully. A prime example of an interval variable is temperature in degrees Celsius. And the final type of a basic variable is the ratio variable. That one is quantitative, has all the properties of the interval variable. So you can order values, you can order their differences, and you can subtract meaningfully. And in addition, there is a true zero. So zero means none of that variable, the absence, the nothingness that we have discussed earlier. This has the result of ratios between arbitrary values being meaningful. So ratio variables are pretty much all real valued variables. So everything that's a real number is a ratio variable. So you can come up with many examples. The interesting part is the difference between ratio and interval, because I mean, here you can see that the temperature in degrees Celsius does have a zero, but it doesn't mean absence of heat, right? Because zero is still warmer than minus 10. So that's why that's like one of the reasons why temperature is not a ratio variable, because you cannot make ratios between temperatures. You can make differences. Interestingly enough, if you have paid attention in your physics class, if you have temperature in Kelvin, then the zero is absolute zero, so absolute absence of heat. So temperature in Kelvin could actually be considered a ratio variable. But I mean, it's less useful for the normal conditions that are around us in weather. So we use Celsius or Fahrenheit. So that is the difference between interval and ratio. So why does all this matter? Why did we just go over 4 types of variables? What's the deal? So obviously there are different statistical techniques from different variables, because information visualization is very strongly tied to data science. You need to be able to process the data. So discerning what kind of variable you're working with will drive your choice of statistical processing techniques. Things like average category, that's a nonsense. So if you have the BMW, Ferrari, Jaguar, Skoda, what is an average car brand, right? It doesn't make sense. And so are statements such as that it was twice as hot in Greece than in Alaska in degrees Celsius, right? Of course, the illustrative examples that I have provided in the previous slides are kind of obvious, but sometimes people can make mistakes in data processing. So it's important in your mind to think of what kind of variables you are actually working with. And obviously, you will also plot different variables differently. So for instance, if you have categories, then if you're going to be drawing a bar chart, that's going to be your categories on the x-axis, whereas your interval or ratio variables are going to be the actual plotted values. So things like that. That's why we set these variable types in stone so early in the lecture. Moving on to visual representation, that's the second part, right? So we have now gotten a brief intro into what the data part means, and now the visual representation. This slide is just to illustrate that there are plenty of fish in the sea. Indeed, you have a very rich toolkit of visualizations that you can use, and bear in mind that no tool is universal, and that there are indeed good practices that exist that we would like to learn in this course. But there is no one-size-fits-all recipe. You need to be able to design your visualizations yourself. So now that we know what data means, what visual representations are, let's unpack the modern InfoVis disciplines. So information visualization is split into, well, information visualization proper, as I like to call it. So the study of transforming data into visualizations. That has 2 subdisciplines. One is business graphics, the other is information design. Another subdiscipline is visual analytics. So those are the tools to analyze challenging data sets. We're going to be discussing visual analytics in this course quite heavily as well. And a special subdiscipline of visual analytics is multimedia analytics, because if you're working with multimedia data sets, so images, videos, text, and audio, there are some specific challenges that make it non-straightforward, so to say. And the last discipline is scientific visualization. And in the rest of the lecture, I am going to briefly introduce these modern disciplines with examples.
Jan, 2 more minutes.
2 more minutes. Very good. So, I mean, let's now is again a good time to stop right away. I would say because we're just going to be starting a new topic. So, are there any questions, comments?
There were no questions in the Discord chat, but just it's a bit hard to monitor if somebody raises their hand. So just for everyone, maybe easier if you just write it in the chat for me.
Okay. So let's change it like this, because I thought that the raise hand is immediately visible. So yeah. If anybody raised your hand, then please feel free to submit your questions. I mean, especially on Discord, or just ping in the chat that I want to ask a question, and you're gonna get the opportunity. So yeah, that's a good remark, and we're going to also change the communication section on Canvas to reflect that properly. All right, so it's 9:52. I'm going to start talking again at 9:57. Then see you in 5 minutes. So hello again. Before we go into the content, I have seen a question from Lawrence that apparently we cannot unmute ourselves and ask questions directly in Zoom. Yes, for this session, this was by design, basically to eliminate random background noises cutting into the lecture. So we have this setup of a moderated discussion. So you can so we had an issue with the raise hand interaction that Christina doesn't see it very well, but for now, let's keep it that if you have a question, just type a quick Zoom chat message like yeah, I want to ask a question, and then she's going to unmute you. If it's going, but I do appreciate direct interaction. So if this is too cumbersome, and if you guys think that that we should grant the unmute directly privileges, then we can certainly consider that. So I do welcome interaction. Yes, Lawrence. But the problem with raise hand is that it's the interface doesn't show it clearly. So if you raise a hand, then Christina cannot see you. So that seems to be an artifact of Zoom. So if you so instead of raise hand, just please write I have a question in the Zoom chat, or you can write your question directly in Discord. But if you want to ask in voice, if this suffices, then let's keep it that way. But if there's if there's a preference for direct unmutes, then we can consider that. I'm not. I do welcome interaction, so please feel free to ask your questions and ask a lot of them. I'd be happy to hear them. Perfect. So if this is resolved, then let's get on with the show. Yes. So before the break, we have discussed that we're going to be introducing various modern InfoVis disciplines. And we're going to start with the first subdiscipline of information visualization proper, and that is business graphics. So business graphics is what you know already for a long time. It's whatever you can easily plot in Excel. Those are the small formatted clean data sets, line graphs, bar charts, pie charts, simple stuff. We have seen that a lot. Business graphics currently, because they have been old, founded by William Playfair 2 centuries ago or something like that. Those at this current stage are a set of good practices rather than an outstanding scientific challenge. Because now, if you would want to be an InfoVis scientist and you would want to devise a plot that is on the level of line graph, bar chart, you would have a very difficult time of it. So it's mostly good practices. The reason why we talk about them is that they are still very important to master, because they are often building blocks for analytic dashboards. So it's still very important to know what's up. But I mean, you might raise the question, okay, but it's kind of trivial, right? So you just plot the data. You take your data, you plot them in Excel or in your favorite spreadsheet tool. What's the big deal, right? And you'll be very surprised how prevalent bad or liking charts are. Some are even deliberately misleading, and this is not me trying to harp on some poor intern that got the job of visualizing something the day before the deadline. Those are organizations that communicate data as part of their job description. So you might see that that there are many important things to take into account when doing business graphics style visualizations. So let's start with tables. As we discussed in the history part, those are a visualization tool, right? And I mean, what can go wrong with a table? So what you see below is a pretty standard looking table from some scientific paper. I mean, this does not come from a particular scientific paper. It's a made up table by me, but it nicely summarizes what we often see when reading about results of scientific experiments. You have your methods. They are classified by type. So if we say wanted to do this little exercise regarding the variable type, so this is a category variable, and all of these are ratio variables. So what's wrong with this, right? You can read the table. Well, we might want to improve this table a bit. So for instance, vertical lines never help anything in a table. If you just remove them, you're removing visual clutter. You're not harming the readability of the table at all. You're improving it. Further, when you're using horizontal lines, then using 3 is usually enough. You're going to use 2 to mark the heading. You can even go lightweight and cut the top line, so you only have 2. But you have up to 2 to mark the heading, 1 at the bottom. There is an exception to this rule, and there are exceptions to most of the InfoVis rules. You will use extra horizontal lines if you want to group row items. So for instance, if you have a table of if you're a retailer and your rows are franchises in various cities, you can group those by region or country and split the regions or countries by lines. So you will have like a logical grouping of various regions and their performance. But if you don't have an explicit grouping of the row items that you want to communicate, just don't use the horizontal lines either. By default, it's best to left align because our eye is used. I mean, especially in the Western cultural area, it's customary to read from left to right. So you left align, and also you want to right align the numbers. That's what we already discussed in the numeral systems section. That allows for an easy comparison of values. But of course, that only works if you have equal decimal precision. So this is hard to compare because it's kind of jumping. If you round up, then you can compare the values super easily.
Jan, we have a question.
Yes.
Like on the slide 47, why shouldn't we use vertical lines for the edges to make a box or to make it a box?
It's a bit of a convenience. So I wouldn't say that using a vertical line on the box is strictly like an error, or if you do it, then your visualization is going to be incorrect. And I mean, I don't have a quick way to plot it, but especially if you combine these 2 rules, you kind of want to. So we would say you would have something like this. It's a convenience thing because then if you're using one of those rules, then you'll say, okay, so why don't we also split up the method from the data, right? And overall, it's best not to box up the values or the data values. They work best if they are free and unencumbered by visual clutter, because then your eye is naturally drawn to the guidelines as well, right? So you want people to focus on the data. So this is from, let's say, perception and cognition point of view, which we're also going to talk about tomorrow, actually. If you don't need the line for a specific purpose, then don't use it. I mean, obviously I can see, but again, as I said, there are exceptions to InfoVis rules. And I could imagine that if you really would have something like a table that is really boxed up in the text, that you might want to avoid text flowing into the table, basically. But then it's a problem of typography, right? Because you're supposed to kind of avoid this by having proper margins and so forth. So that's a bit of a different topic. But so I wouldn't say that it's something that I would consider a grave error, unlike some of the things we were going to talk later. But the simple rule is don't use vertical lines. I mean, you can use them, but I don't see the benefit myself. I don't know if that's a satisfactory answer. If the student asking if you could confirm whether you want to learn more, or other people have questions.
I got a thumbs up for it, so I guess the answer was fine. Somebody else asked, yeah, but you could also use different gray colors for every row as an argument.
Yes, and yes, you can. Yes, so please note that these things that I'm doing here, we're still in the kind of intro part of the course, right? So what I'm showing here is not a comprehensive set of techniques that all the techniques you can use with tables. So you are absolutely right, and frankly, it's actually a wonderful technique for this part. So if you have those groups, you might want to avoid horizontal lines, but you use different color backgrounds. So that's one correct use of the backgrounds, indeed. And the other is, especially in the let's say browser window, or in the computer screen context, if you have a table on your web page, or on your visualization that is on the screen, and you have really long line because of the glow from the screen. It's sometimes difficult to read, especially long lines. So there you might even it indeed might help if you show, if you have alternating colors for background, because it will help guide the user. At any rate, having the alternating backgrounds is better than using the horizontal lines. So that's a great question. Thank you for it. So unless there are many, please, the students that have asked the questions, feel free to react in Discord. And if you need further clarifications, or you haven't been satisfied with my answer, you can please feel free to continue asking. It's just, I'm going to continue, but we can go back if you need some more things clarified, or you want to hear my point of view. Because I mean, now it's a bit of a rambling from my part at this moment, but. Information visualization is not an exactly computable discipline, right? So there are always examples of things being used correctly and conveying less meaning than if you break the rules a bit. But my intent is to first teach the rules before, or learn the rules before you can break the rules, so to say. So hence why it might feel that I'm very authoritative with how to improve this table, but know that those are some of the good rules. We're going to learn a bit more comprehensive set later, and some rules are meant to be broken sometimes, but you have to know what you're doing. So that's my intuition. But anyway, unless there are more additions to this topic, let's continue with the table. Yes.
There are a few more questions.
Absolutely.
A student asks, are there also any tips for table headers, or should they be aligned in a specific way, bold, or any other things to consider? Perhaps you're going to talk about this in a bit.
Yes. So what I have noticed works for me the best here is if you keep the headers left aligned, then basically it will supplement the work of the vertical lines that are now missing and not occluding the text anymore. Because at first it might seem weird to you. I mean, I'm going to jump here because this is how it's supposed to look properly. This might seem a bit weird, right? That you have a left aligned header and a right-aligned value. But this is actually one of the things that Excel does right. That indeed the alignment is driven more by the data type that you're showing in the cells. So generally, the rule of thumb is that if you have a number aligned right, if you have anything else aligned left, yeah. So some people use centered header cells, which can also work, but now we're in the opinion area. It might work better for some people, but for me, I think that this nicely draws the columns implicitly, right? I wouldn't say it's a mistake to have them centered. And if you indeed have, let's say, a compound header, so you would have, let's say, type, subtype 1, subtype 2, then it's even a really good idea to use centered. So you're going to have like the aggregate name in center, and you're going to have the subtypes centered, if that makes sense. Do we have any reaction to this, or?
Yes, thanks. That makes sense.
Perfect. Okay.
We got them.
Any other questions? You said that there were multiple.
Yes, there was another question. So with the numbers rounded and aligned, perhaps you already answered it. With numbers rounded and right aligned, while column names are left aligned, it does not seem too clear which variable belongs to which column without counting the columns. Wouldn't vertical lines make this better?
I wouldn't say the vertical lines would make it better, because then you really have like boxed up values. I think I've answered it in the previous one. It really is better to have it if you feel that this is difficult for you to read, then use the center alignment, right? But it also actually correlates with another topic, like you want to have the correct size of the cells, and also things might be different when you have a super long table, so many attributes. In that sense, I would actually say, and I might even correct the slides. So this is a very definite statement, never help anything. So we might want to say, if you have a really long table, let's say horizontally, you might want to group group meaningful attributes together and separate those by vertical lines. So the same logic as we have with the row separators on this slide. If you would have the franchises in various cities, you can use here. But the super correct answer from visualization perspective is that if you have such a long table that you need to break it up into subsections, then it's a too long table in the first place. So then you might need another visualization. So it's too much of a cognitive load to process it meaningfully with your eyes, as if you just read the table. So sometimes you record tables for the sake of recording. So it's kind of like a data type, right? The table. But if you use the table as a visualization, you want to convey some information, then you might want to stick to tables that are easy to process, and you might want to select only those attributes that have any bearing on the message you want to convey, and so forth. So I hope that this question is satisfactory. But from the point of view of the alignment, it's definitely better to use center alignment here than using the vertical lines. From the standpoint of visualization theory, basically, that you reduce occlusion. Okay. So unless there are more reactions, then let's continue. So this is this is our let's say final form of some of the steps we could have done to increase readability. I mean, one last point is that you of course round up to what's useful to your purpose, but do have a good reason if you want more than 3 significant digits. So sometimes you can have experiments that where the difference is on the fifth decimal place and so forth. So then you might want to use the scientific notation, so times 10 to the power of minus 5. But if you have more than 3, so 4 and more, it's very difficult to read. And I mean, I leave it up to your opinion if you compare if the top table is easier to read or if the bottom table is easier to read. It can be different for, and like quickly see which experiment is the best. And I mean, I'm aware that there is one more technique that can be done to drive this message home, and that is emboldening the best ones in each column. So here, this one would be bold, this one would be bold, and this one would be bold. But this has been because the boldness draws our attention first. This has been done as an exercise like that. Even without that, you can do steps to improve readability. So I strongly believe that the bottom table is much more readable than the first one. I mean, you might beg to differ. And again, in this course, you are going to be designing your own visualization. So if you like the top one better, sure, but I mean, there could be arguments against it from the TAs basically, or from other viewers of your data. But I believe that the bottom one is a bit more readable, and this is an example of things that you can do with a simple table. And it also kind of supports my point that already you see that we have started quite a nice discussion about a simple thing as a table. So if you go further to charts, so the classic is that you always have to label your axes, you always have to give your charts a title, and you should really strongly consider a legend. I mean, I believe that you have been annoyed by teachers telling you this and really emphasizing it since the early days of you drawing your first function on the paper. I'm excuse me for piling onto this emphasis, but it's really important, because the trap is that even if you think the context is clear, like it's clear what I'm showing, how much do you really save by omitting these elements, right? So by not labeling your y-axis and not labeling your plot, because now we'll never know what this plot is, what this plot is, and it's actually a random plot I have downloaded by typing into Google badly labeled plot. So even I don't know what it is. So this has kind of been in vain. So make sure that you always include it, even if you describe. So if you write a paper, if you design a visualization and you think it's clear from the context, because also for citation purposes, sometimes people want to cite your figures, and basically the rule of thumb is that if you do Control C, Control V on the image, it should be self-contained. So sometimes you can indeed have a plot matrix where you're investigating a couple of related things, and you only want to have like one central legend and one central title. But that one, if that's one image, then yes, then maybe for space reasons you might want to omit some of the labels. But in general, the rule of thumb is you're not really saving anything by omitting proper labels, proper titles, legends. So use them. I can recommend that to you. Now we are going to the classic trick to blow differences out of proportion, and that is y-axis starting above 0. Unlike some of the techniques we discussed rather for the tables, this is a grave error. If you're doing this, then you're really manipulating people. And as you see from this example from Australia, from the New South Wales government, people are doing it. So the story is that the government is doing nice things for us, such as recruiting more nurses, and look how it has risen over the years, right, under our government. Amazing, right? So this plot is the equivalent of this. I mean, it looks massive increase, right? But if you start the y-axis at 0, at max 0, so if you have negative values, then you start it at the minimum value. You see that the difference is not so dramatic, right? So it actually constitutes like 7% difference. So yes, the New South Wales government has indeed hired more nurses, nice, but it's not as dramatic an effect as this. So this is misleading. This is an error. If you draw visualizations like this, you are manipulating people. And you can do a little exercise if you want, like if you go through especially like political propagation materials from political parties. Yes, we have a question.
Yeah, one question. So sometimes when you have a table in the bottom row, I'm not really sure. I guess the student wants to know, is there any guidance for the total row? If there is any, probably like how many rows you can cluster like that until you have to start making a visualization.
So the question is, so that I understand it correctly, the question is how many rows you can have in a table meaningfully.
Yeah, I think he would like to know some kind of upper bound.
So I think that tables like row wise or like the vertical direction wise, they are pretty much meant to be infinite. So I don't think there's an upper bound. And there's also a reason why if you run Excel, or your favorite spreadsheet tool, that there is like rather limited number of columns, but you can go to 30,000 rows by default. And that is because scrolling down either on a screen or visually is not such a taxing task for us, because we're used to reading from top to down, but we are overwhelmed if you have too many columns. So you should break up your tables if you have too many columns. But if you have long tables, then of course you might want to use, if you can break it up, it's good. You might want to use the grouping with the horizontal lines. That's better. But if you, for example, want to record a lot of experimental variations, and you want, for the sake of transparency, to record the complete data, then if you have a super long table row wise, then you're not doing it wrong from the visualization perspective, so to say. uh, One thing that you might want to consider if you're doing this on a computer is to anchor the heading, or possibly also the summary row. So if you have a summary row that says total or average or whatever, then you might want to anchor those. So you basically only scroll the data portion of the table. So for each row you can make a comparison with, or you know what each of the columns means, and you can compare quickly to your bottom line, basically.
All right, thanks. I think it's also time for the next break.
Oh, already. Okay. So yes. So let's reconvene in 5 minutes then, and yeah. So now it's 9:24 almost. So 10:29. Okay, in 5 minutes, 10:29. I'll be back to continue about the charts. See you. Right. So hello again, and we're gonna continue with the final part of the lecture. Two technical notes. I have seen that there are some needs for clarifications in some of those questions. Please note that I'm gonna hang out in Discord after the lecture, and like throughout the week generally. So I am gonna tie up all the loose strings directly in chat after the lecture. So if your question goes unanswered live, don't worry that I'm gonna ignore it. It's gonna be answered. And Christina, now please notify me towards the end of the entire session. So towards 11, if because we might need to use up all the time. So yeah, that's just a bit of a technical request from my side. But let's crack on with the lecture. So we have seen that y-axis should always start at max 0 or at your minimal negative value. There is one little hack. You can change the aspect ratio, and that will still highlight the differences legally, basically. So here the difference appears visually lower than this, but I mean it's still a bit of a hack. So it's always a bit suspicious if people start changing those aspect ratios to something crazy, because your eyes expect a plot like this and not a plot like this. But you can in principle do this. Then there's the issue of the double y-axis. So if we consider these two graphs, they seem all right? It's a properly labeled axes. Titles, we know exactly what they're showing, and now we want to understand how the story changes between the two plots. what happens on the left, what happens on the right. And the thing is that that it doesn't, because it's completely the same data, except one of the y-axes was scaled down. Whereas, so the y-axis shows orders, or the y-axis 1, y-axis 2 shows marketing cost, and here it goes up to $12,000. Here it goes up to $8,000. And you can see that it's completely the same data, but the plots look dramatically different, and they seem to convey something completely else. And the reason why this happens is that there is no objectively set relationship between the two axes. It's completely arbitrary. The story, in quotation marks, is arbitrary as well, and changes based on how you set the axes, and this can and will lead to different conclusions. So, for instance, because like the spots where lines cross are important to our eyes, they draw our attention. One of your conclusions would be that on the left something important happened near the 1st of May, whereas on the right it was only near the 1st of September. Well, no, because the crossing of the lines is arbitrary as well, due to the relationship between the axes being arbitrary. So here I can say this resolutely: double y-axis is always a trap. So never use it. If you want to relate two variables, consider plotting the ratio between them, if it's meaningful and if it's a ratio variable. Just a quick shout out. So this piece and the plots are cited from a very nice blog post on funnel.io. You have a link directly in the lecture slides, which I'm going to make available. So I recommend reading the article. It goes into many of these catches in detail. Another issue, and this is a big topic, is pie charts, but pie charts in general as a visualization. So there is a large number of people that think that pie charts are completely useless. They hate them. I'm not part of that demographic, but I still think that whenever you want to draw a pie chart, just ask yourself, why not a bar chart? Because and the reason for that is that humans are way better in comparing lengths than areas. So this conveys the completely same message, and I still maintain that this bar chart is easier to read than this pie chart. This one is cutely colored. This one is seems a bit more bland, but that's it. Other than that, I do prefer this. So I'm not saying that pie charts are wrong, that you can never use it and so forth, but always ask yourself, why not a bar chart if you want to draw a pie chart. And of course, it's important to select the right chart for the right data. This is one of my favorite screwed up visualizations. I actually believe that this one was done so screwed up on purpose. So this plots the dates of Republican Party presidential primary schedule of 2016. You have your states and territories on the x-axis, and you have the day of the month as a bar, and you have color-coded months. So if you want to find Wisconsin, so you say, okay, so because this is not even alphabetically sorted, so I have to search. Yes, here's Wisconsin. So we are at 5th, I guess, 5th of April 2016. Ta-da! And now rinse and repeat for the other 50 states. This is of course horrible. This is a plot to illustrate that yes, it's very important how you encode your information. So you really want to use the right chart for the right data. If a variable develops over time, you want to use a line graph. If you're comparing relative differences between a few items, use a bar chart or a pie chart if you really know what you're doing. And sometimes a simple table is best. So like in this case, if you show this in a calendar, which is a table, then then you're good to go, right? So this is of course a ridiculous example, but sometimes there are levels of subtle ridiculousness that where sometimes you think, why didn't they just use that? So you do, even in like business graphics, you need to really think about your tools. And of course, there's more. So you have many charts that are bad or suboptimal in a certain way, and we'll learn why tomorrow, and maybe the next lecture in perception and cognition. So this one is evidently bad, but you might want to ask, like, what's wrong with this? What's wrong with this? And so forth. We're gonna try and answer those questions. That's a bit of a teaser for tomorrow. So overall, I would say that even though we're now still in the business graphics part, so the part that has been researched for 200 years, and you still see that there are lots of things that might not be so intuitive, and lots of things that people do but they don't work. So and only now we're moving on towards the more challenging parts. Information design, that's another subdiscipline of InfoVis. That one is very popular these days. So suppose you have a story to tell or an information to share, and you want to tell it convincingly, supported by data. Information design, those are infographics or data GIFs or animated infographics, which is the better umbrella term. And they are very widely used for example, in political discourse and news reports. So this is, as we discussed, this is an example of a beautiful infographic, the story of Napoleon's campaign through Russia that we discussed earlier. And here there are other examples of infographics. So you have the global carbon footprint. So each country is proportional. The size of the circle is proportional to its carbon footprint. They're color coded by continent. So they convey the message of which countries should enhance their ecological game. There's also the example of emissions to Mars and the more kind of dashboard style infographics piece on oil spills. So you have multiple charts telling the story about the problem of oil spills. There are a lot of bad infographics. There is an excellent article on Mammoth infographics. Again, you have the link in the lecture slides. I recommend you read it. There are some beautiful examples. This is one of them, quoted from that article. So this is a ridiculously bad infographic, right? It doesn't sum up to 100%. So you can immediately see that the total value is way higher than 100%. So you would kind of expect that you would say that the baby boomer generation, this is like one of them, and it would kind of give you the ratio of his or her skills. It's completely ridiculous. Like why are individual parts correlated to various parts of the body? So you being creative is apparently in your feet, and so forth. So lots of those bad infographics that don't really make much sense, honestly. But moving on to some of those that are a bit nicer. So let's wait for this to load. So this is a beautiful example of the history of Europe. So if you play the video, I mean, it's 11 minutes, so we're of course not going to watch all of it. It's a map of Europe, like the countries in Europe for every year. So let's jump to a random point, and you see the year develops. I mean, not much is happening here, but the years are the animation. So like each frame is a new year, and you see how the borders develop. Let's go to, say, here, and you see new countries coming to existence, changing their borders and everything. This is a beautiful, straightforward, intuitive, animated infographic, and it uses animation as to signify the passage of time, which is one of the most natural ways to use animation. Credits to the Kotoro channel on YouTube, so you can watch the video later if you want to. Another beautiful animated example is this infographic by Tabletop Whale. You can see the original following that link. Here you can see how a human develops from a single cell to the newborn baby, and you can indeed follow one of those all the way to birth. You have beautifully marked individual weeks of development. This is just great design. This is just a great example of animation in infographics used right, in my opinion. It tells the story. It's not there for its own flashiness sake. Amazing. Generally, information design, the best practices, you always have to have a clear point, what you want to tell, but that holds for many visualizations, not just for information design. You really want to avoid flashiness for its own sake. Lots of infographics have some three important data values, but they have an A4 of graphics, and especially you have to avoid that with animation. Have a clear reading flow. Sometimes infographics have a tendency to overwhelm the reader, so which you want to avoid, and be careful about bias or downright BS, both as a creator and a reader. Infographics can sometimes be manipulative. Moving on to visual analytics. So visual analytics, those are the complex tools for complex data, well, intuitive tools rather for complex data sets. The official definition is that it's the science of analytical reasoning facilitated by interactive visual interfaces. I mean, this is a very content-heavy slide, but I felt the need to unpack the definition in a bit more civil terms. So suppose you have a domain expert. It can be, let's say, a medical scientist or a police investigator. They want to solve a certain problem. So a policeman or investigator wants to investigate a suspect's seized computer, or the incidence of the medical scientist will want to research the incidence of a disease in a population. The solution will come from analyzing a large complex data set, which cannot be feasibly analyzed by normal means. So the data is there, but you have no ways to access it. So visual analytics to the rescue, they will build a system or a tool that will allow the experts to analyze the data iteratively and interactively. Those are two key components. Iteratively, because it's a complex data set, it will take time and a gradual approach to grapple with the data, to gain understanding of it. You cannot do it with one click. And interactively means because static visualizations don't cut it. You cannot just like watch images fly by and gain insight. The expert has to perform many subtasks to progress, and the hands-on approach really helps understanding. So visual analytics is interactive, iterative analysis, basically. This is an example of a visual analytics system, OmniSci. Here we have a nice COVID dashboard, and you can see that the individual components of the dashboard are exactly the business graphics kind of plots. So this is why it's important to master them before we move on to possibly visual analytics. If we recall in the InfoVis pipeline, I have told you that it's drawn a bit weirdly, and I'm going to explain why. Well, here it is, because the visual analytics pipeline looks like this. It adds model, because for the analysis to be intelligent, for the system to guide you meaningfully towards your insight, it will have to maintain a model of the data that and will have to synchronize with the user. So in addition to the pure visualization pipeline, you have a model that of course analyzes the data. It can update itself, and the main new trick is here. So the model drives the visualization. The user interacts here, and the visualization drives the model. So the model learns from the user throughout the analytics process, and the resulting knowledge comes from both the visualization and the model. So that's one of the differences between InfoVis. There is no model; all is in the views and in the visual representation. And here you have visual representations supported by an intelligent model. So this is why visual analytics and multimedia analytics especially is becoming more of an AI discipline every year. And now the difference between visual analytics and information visualization, or I mean, it's a bit of a terminological mess, because the entire field is called information visualization, and its parts are information visualization again and visual analytics. So now we're talking about the difference between these two, not the difference between the subpart and the whole. So the classic InfoVis, in the sense of the simplified pipeline, focuses on the individual visual representations of the data. So if you want to design an innovative visualization, you really are designing a new way to represent the data, or new way to interact, new views, and so forth, basically a new graph or a new chart. Whereas visual analytics, the goal is to enable tackling data sets otherwise thought impossible. So if you have an innovative visual analytics tool, then you're improving the flow of the analytics process itself, but your visualizations that are part of the dashboard do not have to be innovative for you to have innovative visual analytics tool, if that makes sense. So as we have seen here, none of these sub-visualizations are anything new, by the time OmniSci rolled out. But together, they give good insight into a problem, which is global confirmed COVID-19 cases and spread. So you're improving the flow of the analytics by using the right visualizations for the job, and having a model that is below the visualization to support it and drive it meaningfully, to save the user the time from tediously processing one item after another. You can also roughly divide disciplines by data scale. So this is by no means authoritative or that this is like a rule set in stone. So, but it usually works. So business graphics usually deals with data sets of tens of items. Information design is hundreds of items to thousands. Information visualization as the full kind of discipline operates with thousands of items and tens of thousands of items, and visual analytics is for those large inaccessible data sets. So we're talking hundreds of thousands to millions and beyond items. So again, this scale is not, I'm not saying that there cannot be a meaningful visual analytics system on hundreds of items, but this is generally how you can split it by scale. And the last discipline of information visualization is scientific visualization. So here we can see a couple of examples. So 3D model of a brain and 3D model of winds near some coastline. So that seems like some kind of a hurricane. So scientific visualization, those are these models, very often 3D, of scientific data, widely used by medical sciences, astronomy, physics, meteorology, and whatnot. But this is beyond the scope of this course. This comes with its own set of challenges, and we will not be able to cover this in this course. But just so you know that this field is also part of InfoVis, and they contribute to the main conference of the field. So speaking of, or to conclude with the objective of InfoVis from the user perspective, it's to gain useful knowledge about the data, as we have mentioned. This is often also termed insight, understanding, etc. And in broad terms, this is you have seen in some of those definitions, there was this phrase amplify cognition, enhance the way you think about the data. This is also what is meant by that in some of the definitions. Of course, you might correctly remark that useful knowledge is rather a vague term. It indeed is, because its exact parameters depend on the task. Depends what you want to accomplish with your visualization, and especially with your visual analytics system. Do you want to summarize the data? Do you want to enable quick searches? You know, so it depends. It depends on the task. We're gonna go into detail throughout the course. And the objective of this course, why we are all here, is we want to teach or learn good visualization and visual analytics design, and even on challenging data. So I would really like the course to be design focused, so that you have some nice particular takeaways that will help you in your future career. And of course, we want it to be solidly grounded in InfoVis and visual analytics theory, but design first usually. Now, okay, so this concludes the part talking about introducing InfoVis, and now a couple of remarks about the organization of the course. So the lectures are going to be 9 to 11 Monday, like today, or Tuesday 13 to 15. The entire course will be online, regardless of the pandemic situation. So we're going to be meeting on Zoom. And my office hours are by appointment, so please don't hesitate to send me an email if you have questions or want to meet me. Better yet, it's actually good to send your question via Discord into the appropriate channel for each of the lecture, because the answer could be useful to others later. So what we want to have, so the combination of videos and Discord, we want to create like a secondary studying resource. So you can feel free to send me emails. I will try to respond to them ASAP, and we can schedule a consultation in standard working hours if you need to talk to me. But please prefer Discord. If you're asking a general question, please prefer Discord. I'm gonna be hanging out in Discord, and we'll be trying to answer there ASAP, much like email. Regarding the exam, so that one is also going to be online. I'm going to be releasing a trial exam during the course, well ahead of the actual exam date. Don't worry. and very highly probably the exam will be design focused. Change is reserved there because there's 200 of you, so I might need to think about how I'm going to grade all these exams. But there highly probably will be you designing a visualization individually in some way, shape, or form. The exam material is going to be the lecture slides. I am trying to make them as self-contained as possible. That's by far the main resource. Then there might be some required reading, so some extra resources that will be also part of the material. I'm going to try to keep them down to a minimum, or ideally 0. But if this comes, they will be clearly marked as required reading, so that you know that you're supposed to study those as well. And there's going to be a lot of optional reading, so which the exams will not cover unless excerpts from that optional reading is part of the slides or required reading, of course. And these are pretty much recommendations for the interested student to enhance knowledge. So my recommendation or optional reading is, for example, the blog post, let's say. Regarding the practical work, so this week there's going to be a tutorial session to bring people up to speed with relevant programming techniques that you will need to design your visualizations. And beyond that, there's going to be a group project. You're going to write a scientific paper on an information visualization or visual analytics topic of your choice, and this will involve actually designing some nice visualization. What is very important, the group formation for the practical starts now. So please form groups of 5 people ASAP. They can be mono or multidisciplinary, but if they're monodisciplinary, know your strengths and limitations. So if you're, let's say, not so heavy on programming, then you might want to avoid heavily implementational work. The team formation starts today, so you can sign up to a team via Canvas. You click on People and Course Project. You can sign up alone. You can sign up with a group of friends, whatever you prefer. But please aim for having the teams formed by this Thursday already. And if you need assistance with finding a team or joining a team, please contact Christina. She's going to be organizing the team matchups, not me. So feel free to contact her if you're in need of assistance. And regarding the schedule of the practical work, because this is a bit confusingly scheduled on Datanos and on the official channels. So this week the tutorial will run on Zoom on Thursday 11 to 15 as per the schedule, and subsequently each team will be assigned a particular TA and a particular time slot on Thursday, and within the time indicated in the schedule, when you will meet with your TA to discuss the project. And you're not gonna be joining other sessions. It's just your one session to coordinate with the TA. And important, there will be no practicals on Monday. So there are some practicals scheduled for after this lecture. So nothing's gonna happen. So this you can ignore. And on Monday you only have the morning lecture. And there's this group A to group X split in the schedule, and you can ignore that as well. So the important part is your project membership, and that you're going to be working on your practicals and attending the lectures, pretty much. So note that the lectures are not synchronized with the practicals. So everybody chooses their topic freely. So there is no default order of topics. Different people will need different topics. But my aim is to cover the general topics ASAP and then progress to specialized ones. And finally, the grade composition for the course, 50% of the grade is going to be the individual online exam based on the lecture material and required reading. 50% of the grade is going to be for the group project. And there's going to be one more individual tutorial assignment, which is pass-fail. You need to pass it in order to complete the course. But don't worry, this is there to help you identify your weaknesses, if any, when it comes to the programming skills. So the TAs are going to guide you through the assignment if you need help. So this is not meant as a filter of students or anything. We need to establish a certain baseline level of programming knowledge so that everybody can contribute to their group projects. This concludes today's lecture. So from today, there's only optional reading. Thank you for your attention. And now, if there are any questions, we can we can take care of that. And I'm going to answer all unanswered questions on Discord after the lecture. And I'm going to try to upload the video and slides ASAP so that you can access it from Zoom. Thank you. So do we have any questions, Christina?
Yeah, a couple of them. One student asks if there's any InfoVis conference coming up, which he could join during the course.
So during the course, nothing that I know of. Maybe Pacific Viz. I'm gonna I'm gonna verify this. I'm gonna take a note and I'm gonna answer you in Discord right after the lecture.
Okay. Other than that, it seems there's more like a discussion rather than questions. I think, yeah, perhaps it's easier than if you just answer them now after the lecture right away. Other than that, I'm going to reply to the organizational questions.
That's perfect. So I'm gonna go over Discord. I mean, maybe like in half an hour, so it might not be right now, but you will receive your answers ASAP. Okay, so we can dismiss today's session. So thank you for coming, and I am going to see you tomorrow at 1. So take care and make sure to form your teams. Bye bye.